I have a question. Where is your quantum computer?
It's on AWS at the moment.
Okay.
So part of this is really like, I think what Deidre was saying about, quantum chemistry algorithms. We've got the tools. We can run these things on our supercomputer for the simulators. But actually going all the way through to like, okay, here's a real qubit, and these domains don't work, and these domains do work, and this is the number of shots you're going to have to do to overcome the noise, and you have to kind of stub your toe on all of those particular challenges at the moment with quantum computing. Mm-hmm. And so a lot of this has really been around, what's the team of people that we need to put together, even just to understand the technology as an applied science organisation. So we're very lucky to have folks like Deidre who have a background in quantum chemistry, but also kind of the supercomputing expertise and cloud expertise that we can kind of bring together.
Because the question was a little bit aligned. I can't remember. We had that conversation a day or two ago. Again, maybe it was with Manish or someone else, telling the story of what doesn't work, not just. So you are starting something, building something. Are you documenting this journey? Because so far we are relying on a tremendously bright and enthusiastic person. Can you replicate that in other institutions? Can we create a pattern of how to work? And then the day that you go and buy whatever instances in AWS, IBM, or whatever, say, wait a minute, I'm not buying for this. I'm having a package, and you offer me, not I am asking you. It's just an open comment. Is there any question from the floor? Mark.
Thank you, great talk. Going back to the flooding, which is super topical, shall we say, I was wondering, you obviously need very detailed models of, what's the shape of the river and, the elevation of the land and stuff like that. I'm wondering what your thoughts are on how frequently those would be updated for past events. And a couple that I can think of is the floods last year changed the shape of the river, and also the storm last week made the ground all soggy, both of which would seem to affect those forecasts.
Yeah, it's very annoying. You do have to kind of rerun a lot of this when the DEM changes. It's kind of another argument for being able to do things a little bit more efficiently, is that you can start running this, and if you can kind of get the model to be understanding a little bit more information about the terrain, then theoretically you could change it and have it still be able to make efficient predictions. So that's part of the motivation for it. But yes, it's definitely, I think the Westport, for example, is pretty robust because the bull is so chunky. But yeah, that is definitely a trait that the hydrodynamics people need to rerun the data sets and things like that when the DM changes, and that is, something that's difficult to avoid.
We do have some other bits of work around using drones for high resolution river mapping and all of those kind of things. There's quite a lot of sort of hydrodynamics, sedimentological work that we do in other parts of the organisation, which actually interestingly includes things like fake rocks. So we have this program where we toss boulders into the top of the Rakaia and we see where they go in flood events, and again trying to understand this really dynamic interplay between these events that we're seeing impacting us and then the flow-on effects, sort of long-term flow-on effects into either local farming communities like Ashburton or offshore and into kind of fisheries and shellfish and all of those sorts of things as well. So it's quite an integrated program of work, of which forecasting the thing is one thing, but then how do you measure what's happened and how do you help communities prepare for the next one is a very, very big part of what we do.
Thank you. You partially answered my supplementary question, which was, the drone mapping. How sort of agile is that? Can you do it after last week's or last year's events to have an updated model, or is it?
Yeah, we're reliant on funding like everyone else. I sometimes joke we're sort of vultures. It's like we get one of these terrible disasters and then government goes, we better fund a bunch of work to see what's happened. I think sometimes it'd be nice if we funded the prep work beforehand so that we didn't have to then be the vultures. But
so the good news is we're getting plenty of disasters.
Yeah, I mean, so for example, I guess we had Cyclone Gabrielle a few years ago now, and there was a fairly large investment of science time into understanding the impact. So we mobilised our research vessels and looked at sediment off the coast and all of that kind of stuff. Plus, drone mapping for landslides and all of those kind of impacts as well. So a lot of that is now sort of starting to feed into our operational work. So it's and one of the joys of us being merged is actually we can start to go, oh, landslides aren't in GNS anymore, they're in ESNZ. You know, we're not trying to connect GNS to Met Service, we've got them all under one roof. So that's really exciting.
Karen?
Yeah, I'm curious, when it comes to the investments and the modelling capabilities, I'm curious what fraction is on the machine learning side and what fraction is, you know, trying to add additional physics capabilities, and also how you see that going for the next, say, 5 years.
Yeah, I think it's definitely been shifting over time. So for example, if I think about the investments into the physics capabilities, that's traditionally where we've had very, very large investments. And I would still say most of our expertise is in that kind of physics-based models area of things. What we have done, I think, on the machine learning side is we've had a centralised team, which Deidre is a part of, to try and then have rather than saying it's got to be one or the other, it's like, can we have both of these sort of things happening at the same time so they can learn and feed off each other? So I think where we're going to is we're quite mature in the physics model version. If you think about that, we've got an operational supercomputer that runs these things 24/7. We know how to make that work. We're less mature in the machine learning, but it's very rapidly getting up there, and we're starting to ask those questions like, what GPUs do we need? How do we make that work so that we can get these kind of benefits? So that's where that's at. And I think where the quantum computing work is okay, this probably isn't happening for 10, 15 years, but we need to start thinking within our capital cycle at some point how we're getting access to those things. And again, this is all research to operations. This is what kind of drives us really. So I think for us, it's going to depend on how quickly we can improve the capability and the what's the word I'm thinking of here? The robustness of what we're able to do, really, and that's kind of what drives a lot of our investment, rather than sort of pure science per se.
On that topic, on robustness precisely, did I see on one of the slides Riskscape or something like that, which, if I'm not wrong, is Catalyst help? Of course, it's a plug from sponsor to sponsor in New Zealand or whatever.
Nice.
She's new, she's laughing. But my point is actually linked to what are we going to discuss later about robustness and open source. You have that system, don't get me wrong, it's just standard software. It's just a software that you put together in a way, but suddenly, how do you see that going all the way into your quantum ambitions? Because it's a little bit of what we discussed with Ilkay about composable systems. So you had a lot of moving pieces, and those pieces still need to give reliable answers for the society. So I guess that's why I'm trying to think in loud voice is we have to put things together as a nation, robust systems that needs to be maintained professionally, robustly in New Zealand, but you also integrate with every other software that you bring into the equation, which is not all New Zealand made. What do you comment on that? Or the question is, have you done a risk assessment about the integration of all the things that you put together into this?
Well, I think that's what we're trying to do, right? Okay. And part of that is actually just getting your hands dirty and doing that kind of stuff. I guess my question yesterday to Satoshi and some of the panel around how a QPU is going to work alongside these systems. These are the kind of questions that we're trying to work out. You know, are we in a world where we're going to have quantum processors in the loop of one of these kind of data assimilation operations, in which case I need to work out how I buy one and put it alongside our supercomputer, right? Or are we in the world where actually I could, have a negotiation with the Australians and I only need this thing once every 6 months and I'm going to punt a bunch of data across the Tasman and do it there and then bring the results back in some way and my operations are completely classical, right? So there's a real kind of interplay and understanding kind of how tightly coupled these things have to be, that we're just really trying to understand.
Because it's also a management issue, because you mentioned the Australian, brought to my mind the synchrotron. It's just a business model that you apply from technology A to technology B, but
Yeah.
Is this applicable? I'm just showing off that I know a couple of words. I'm not saying that I have an idea.
We're very mercenary, so if it saves us money or saves the government money, then we'll do it. So that's ultimately what it comes down to.
Any other question for these fantastic people, which I really commend the work that they have been doing. To be yes, Shane, there is a microphone behind you.
Since we're talking about things that have happened, I'm wondering, Three Waters was an ambitious idea to sort out our water system, and a lot of what you do seems to say our water systems are not coping. I just wish we could save money by using the predictions to make sure that we actually fix things before they get buggered. And so I do feel like a lot of what we end up doing as scientists is going around where everything's already been buggered and trying to figure out, okay, how do we deal with this in the future? I just wonder whether we should be much more proactive and whether government's ever going to listen to us, or are we just going to continually be following disaster after disaster?
Before you answer, just for the international friends, there is a local context. He mentioned Three Waters, which was a
policy. Yeah.
Yeah.
It's a government policy. It's come and it's gone. I guess what I would say is when we're engaging on hazards, it's not just response. It's not just recovery. It's not just resilience. It's right across that whole spectrum. So I mean, to the work we've been doing with Catalyst around Riskscape with Don and the team, a lot of that is really around that kind of how are we actually thinking about, rather than stopping Westport from flooding, moving it. Move the city, which is now a political discussion that is happening with that community, and it's quite a fraught discussion, understandably. And I think it's those kind of long-term things where we're bringing this through not just from the weather forecast to what's happening in a particular event, but we're also bringing it through to those kind of nationally contiguous flood maps. Insurers start to look at those, they start to make decisions off the same sort of sets of data. We can go down to the sort of the per house level, and we can start to say, if the government's trying to target resilience in a community, how do they target that best? Should they be targeting people that are less able to help themselves? Or should they be exiting communities and not being the insurer of last resort? So a lot of that work gets done with the Natural Hazards Commission, which used to be called EQC. And a lot of that work has come off the back of actually what happened here in Christchurch after the earthquake. The government just can't underwrite all of this stuff anymore. We will go bankrupt. So that's it's a big political question, I think. But I would say the government does feel the pain because they actually end up paying for it a lot of the time. And that is changing. Every time we see one of these events, we're seeing more and more about how do we address the resilience questions, not how do we just do a response immediately after them.
My comment on this, back to Ilkay's presentation, a little bit of what Simon said about what Bristol is doing and this. At the end of the day, we are facing the same problems. There are orders of magnitude about the scale or the country or the resources, but we are facing the same problems. And then I wonder, just as a guy who lives in Wamaru, shouldn't be having a pattern about how to face those things, and then you just regulate the order. It's just a comment. Brings me back the reflection of the open source model is always ready to help. But what do I know? So, are you shopping for a quantum computer? Are you standing behind a banner that I can leverage for?
Well, I guess with the proviso that we certainly don't have the billion-dollar budgets of our Japanese colleagues, unfortunately.
I will find you a deal.